Hey everybody, this is Larry. This is the last day of the July Leetcode daily monthly challenge or whatever. Hit the like button, the subscribe button, or join me in Discord, and let's get started climbing stairs. You're climbing a staircase. It takes n steps to reach the top. Each time you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Okay. So that seems pretty straightforward. In the sense that this is pretty typical, and that this is just a Fibonacci number, right? And experience will let you figure that out immediately, but if you really want to, you could also just try to think about it in terms of dynamic programming, right? You could, and in this case, the dynamic programming is symmetric, and what I mean by that is that it takes, it's the same going from the bottom of the staircase going up or from the top of the staircase going down. Whichever you feel is easier for you, you can do. But and I suspect that because so Fibonacci's number, the 40, it's about like 1.6 to the n, slightly less than to the n. So I suspect this is to keep it inside int. But yeah, so the idea is, since it's Fibonacci, but if you don't recognize it's Fibonacci, the idea is that, okay, so let's say we're on the nth, let's start at the top, right? I mean, you could start at the bottom, like I said, it doesn't really matter. But let's say you start at the top, it takes n steps to get to the bottom. Well, how do you interpret that, right? Well, that's just, there's the two things you can do, right? One is walk 1 step down, and then the other one is walk 2 steps down. And then that's pretty much it. And then you kind of build that recursive structure and then count, sum up all the counts. And then we're going to do that. Yeah, and of course, if you do recognize that as Fibonacci number, of course, you could actually do this in one operation or whatever with math.power or something like that. But we're going to just do it the normal way with with Fibonacci. And of course, for me, I am going to write it out how I would talk about it. This is a very introductory problem. I suspect that they just forgot and then they just add a random problem. But I'll link on my video how to convert this to bottoms up, and then also just remove the space. So yeah, definitely play around with that. But I'm going to just do it recursively with memorization because it's just an easy way to think about it as well. But yeah, but it should be straightforward otherwise. So let's just have a count, and then you have naming variables is hard for me, but let's just call it index, say, or steps left. If steps left is equal to 0, then we return 1 because that means that you're at the bottom, and there's only one way to get from 0 step to 0 step, right, by itself, because you're already there, right? And also we want to return count of n. And then now, I guess there's some test cases. And then now, if steps left is greater than or equal to 1, let's just do total is equal to 0. Then total plus is equal to count of steps left minus 1. And then also if steps left greater than 2, we take 2 steps this time. And then now we just return the total, right? Okay, cool. Let's play around with it. 2, 3, 5. We can put. Oops. Let's just keep it small for now, just to see if it runs, or give us the correct answer. So I do know that this looks okay. So I do know that it's going to run out of time if we give it a big number. Why? Because, well, this takes a long time to run because for every step, you sum up all these ones, that means that it takes that many steps, which this will take way too long. So what we do is we're going to do something called memorization, which is the top-down dynamic programming. And the thing to notice is that how many different unique inputs are there to steps left? Well, there are n, right? Or n plus 1 from 0 to n inclusive. So that we could just, keep track of caches that way. Let's just call it count cache, say. Oops. Is equal to 0 times n plus 1. And then we could do is count cached is equal to force times n plus 1. And of course, there are different ways you can do the caching. You can use hash table and you could use LLU cache. There are other ways to do the caching, but I like doing it this way on stream just to kind of for illustration purposes. But yeah, but in this case, we can just do if is count cached. That means if this answer is cached, then we return just the count cache, right? Otherwise, at the very end, we go if is count cached steps left is equal to true. That means that we did the calculation, and then we set count cache steps left is equal to total. And again, because 1.6 to the 45th, roughly speaking, is less than fits in 32-bit signed in, so you don't have to do any model worry about anything like that. And you can see that it obviously runs in time. So we're going to submit, and there we go. Yeah, so what is the running time? Well, there are only n plus 1, but O of n possible inputs, and each of them do O of 1 work. So this is going to be O of n running time, and as you see, we do is O of n space. Again, you know, if you are familiar with Fibonacci, then you will recognize how to do this bottoms up, perhaps. And then, because if you're also familiar with Fibonacci, then you may recognize how to save space by getting into O of 1 space, which you definitely can. And if you also recognize Fibonacci, there's some formulas that you could play around with, but that's, you know, none of that is really necessary. I think this is a good start. Yeah, and I'll post a link to the dynamic programming video in case you want it as a reference. But yeah, pretty straightforward problem, pretty simple. That's all I have for this problem. I hope y'all have a good July, had a good month. Hope August is great for y'all as well. And I will see y'all next month. Bye bye.